Welcome to this episode of Architectural Simplification. In today's episode, we'll be looking at the dual write problem, specifically relating to queue coherence or incoherence. As with the previous examples, there'll be a before and after scenario, which will look like this. We'll have a stock service that will be writing stock to a system of record database and a queue, so it'll be performing two writes, and we'll have a consumer that's polling for database changes from the system of record and a consumer that's waiting for push notifications from the queue. The after scenario will involve the service writing to the same system of record, but this time the system of record will be responsible for publishing transactionally consistent messages to the queue, rather than the service doing both of the writes. I'll still have a consumer polling for database changes and a consumer waiting for notifications from the queue. We'll see how both of them behave, but more importantly, how in the after scenario, the application code is simpler and safer. In the before scenario, I'll be creating a CockroachDB node and a Kafka node, or Red Panda in this case. The application will connect to Kafka for both reading and writing. In this example, I'm performing dual writes, and I'll connect to the database. I'll maintain two views of the stock, one in the database and one on the queue. So potentially they could drift over time. I'll simulate a polling consumer whose job it will be to, at a given interval, fetch the data from the database, and a queue consumer whose job it will be to wait for notifications from the queue and update the queue quantities. And I'll also start a producer whose job it will be to, at a regular interval, simulate a write to the database and then publish a message to the queue. The astute among you may realize that this is where the dual write problem comes into effect. If the database write fails for any reason, we're okay because the whole thing would have failed by that point and the function will return an error. If the database gets written to, but then subsequently fails before the queue can be written to, then we're in a weird situation. The database and queue are out of sync. I'm not simulating any failures in this example. It's more to show you about how the code is simplified in the after scenario. And then I just have a print loop which prints out the database quantities and the queue quantities. The after code isn't actually much shorter, but where it becomes a lot simpler is in the producer. I simply write to the database and that's it. I don't have to write to the queue as well. So if my write to the database fails, nothing gets written to the database or the queue. Let's run these scenarios now. This is the before scenario. So I'll spin up my CockroachDB and Kafka or Red Panda containers. I'll connect to CockroachDB and create the stock table, into which I'll just insert a canned product. Next, I'll run the application. The polling consumer will run at a rate of 1 request per 100 milliseconds, and I'll be making a write around 4 times a second. So what we'll see is as it comes up, the queue consumer doesn't receive a message for the first couple of iterations, but when we get to about 8 or 9 database requests, we'll start to see those appear in the queue. And what we can see is it seems to be uniformly one behind. That is more of an issue in my application than an issue in the dual write pattern. But what's important to note is that at any time, the database consumer and the queue consumer can have a different view of what is correct in the database. The queue and database will occasionally match, but sometimes not. That's not the main issue. If a write to either the database or the queue were to fail, that's when the real problems start. Let's see what does happen in the event of an error between the database write and the queue write. Perhaps your business is processing something like payments, things that can't go missing, things that depend upon the guarantees of at least once or exactly once delivery semantics. I've updated the application such that it now checks for the number of times that I write to the database and the queue, rather than the validity of data between the database and queue. For around 1 in every 100 requests, I will fail before writing to the queue. This will simulate a transient issue in my application, either at the point of writing the message to the queue or just before writing the data to the queue. We'll assume that data has been successfully written to the database. If I run this application, we'll see that I'm writing to the database and to the queue, but this time the missed messages have nowhere to hide. In the event that I miss a message on the queue and I don't need exactly once or at least once delivery guarantees, it doesn't matter if I lose a couple of messages. My application will catch up once later messages are published. In this scenario, however, let's say we're performing payments. There are payments going missing in this scenario. If I stop it there, my database at the time of stopping the application was aware of 469 payments, but my queue was only aware of 430 payments. 39 of those have gone missing. This time we'll work in the after scenario. I'll start my Red Panda node And I'll also start Cockroach Demo, which runs a local enterprise cluster for testing purposes. This is all part of the Cockroach binary, so you can run it yourself at home. I'll create the same stock table and same canned product. I'll be taking advantage of CockroachDB's CDC change data capture functionality here, and what that will do is publish notifications when any data within a specific table changes. For example, in the table that we're dealing with, if a new row is added, updated or deleted, a change feed notification will be published so that downstream consumers know that something has happened. I'll enable range feed notifications, and then I'll create my change feed. Whenever anything changes in the stock table, we'll publish the product ID that changed and the new quantity to a topic called stock. I'll run the application again. And as before, once the database has had a couple of writes, the queue will catch up, and they tend to match. This isn't always going to be the case. The database pollers aren't always going to be receiving exactly the same notifications at exactly the same time as the queues, because they might be polling at a different refresh rate to the queue notifications. That's not the benefit of this after pattern. The benefit is it's safer execution and it's simpler application code. Events are published in the correct order, so we know that we've got transactionally consistent data, and you probably wouldn't want to have a separation of some consumers being polling consumers and some consumers being queue-based consumers. You probably want to move all consumers to be working against the queue, because that way they all get notifications at the same time and you're not potentially overloading the database with unnecessary requests for information when the database hasn't changed. To harness CDC in CockroachDB and achieve what's called the transactional outbox pattern is a much safer approach to using dual writes. You remove responsibility from the application and you're always going to get transactionally consistent data on the queue. So any consumers of the queue are going to receive good data. And perhaps most importantly, if your queue gives you guarantees of at least once delivery or exactly once delivery, these will all be broken if you're performing dual writes.